Well, welcome to the stream, Vincent. We'd love to have you.
Hey,
How you doing?
There he is.
Perfect.
What's going on?
big fan of the show,
A couple months
so thanks for
ago.
having me.
Yeah. Thanks for joining. A couple months ago, we had Bridget from Founders Fund on, gave us the high level overview, but I'd love to get it from you. Can you just introduce yourself and the company to kind of kick us off?
Yes, so my name is Vincent, and I'm the founder, co-founder and CEO of Prime, and basically our goal really is to commoditize AI and compute more broadly. Really also by almost like networking all the compute in the world together and making sure like no GPU goes idle, but rather can contribute to almost like an interplanetary like compute cluster that can like fund, for example, open source AI models, but also that people can just like use to ultimately save on like compute. Like ultimately, the goal really is realizing that like compute is this like gigantic market which will ultimately power all of those different areas, and it's quite inefficient and very distributed. So a lot of it is ultimately like research challenges to make sure we can like network compute that is like quite distributed throughout the world, but also like verified, right? It's like you can't trust like the thousands or like millions of different like data centers and like the GPU nodes distributed across the world. So there's basically like a challenge to scale trust. Right?
Yep.
It's like you can trust one data center or one company, but it's hard to do so at scale. So basically, we're tackling those two problems.
Okay.
Why don't you talk about the launch Sunday?
Yeah.
You guys, I hadn't seen the launch like that on a Sunday since the last seemingly few Trump executive
Super Bowl.
orders. So you guys kind of realized
Super Bowl
Sundays,
Sunday.
yeah, Super Bowl Sunday. Why not launch a new model? But break down the launch just a couple days ago.
Yes. So basically, we like kind of like to take a step back, almost like did this first very large scale distributed pre-training run into like one which was building on like DeepMind's distributed low communication training to train basically a model across the internet, across multiple data centers in similar efficiency as in a centralized setting where where all the computers network in one data center. And now that we switched to this kind of like O1, like post-training, like reinforcement learning paradigm, it's actually kind of like a paradigm that is like perfectly set up for distributed training.
Got it.
Because most of it is like those rollouts, and basically you can distribute them extremely well. Like there's basically less needs to communicate every training step. So what we did with like Intellect 2 was really scaling to like the larger model size, like a roughly 30B model that we basically trained, distributed across the globe with different people contributing compute, and really basically built this on top of Qwen. So basically the goal was also to like take the best open models out there and improve them further for like actually quite small amounts of compute. It was honestly like more like a proof of concept where we basically proved four different pieces. Like on the one side, basically we proved this like verifiable compute piece that basically anyone in the world could join with their compute. We don't need to trust them. There's very like efficient basically ways to like make sure that they're basically like an honest contributor. And then the other piece was really making like basically distributed reinforcement learning work. So basically decoupling those like role generations from the training itself. So you basically can train across the globe with like less frequency of communication. And what we basically proven is that like with quite a small amount of compute, like roughly $100,000, which is not comparable to obviously kind of like the more like close AGI labs, we've basically been able to like improve upon Qwen, and it's kind of like sets the foundation for us to actually scale this much further and ultimately actually have kind of like a repeatable recipe to get like basically improve like the strongest open source models out there continuously for quite like small amounts of capital across different domains. So we made it much better on math and coding, but the goal is also to make it much better on like other domains. And really like how to do so is like really scaling those like reinforcement learning environments. I think you had Will Brown on, like he joined us to work on this.
Yeah, I was gonna ask
massive
what was
deal.
what was the process like recruiting the big dog, WB?
Absolute dog.
I mean, I just have to imagine he's such a good poster. He's such a great guy to chat with. He could have gone anywhere, but he ended up with you guys.
Yeah, I think it's two things. Like you should ask him himself, but I think like a lot of talent is gravitating more towards like open source AGI and like to basically build in the open, to publish in the open, right? Like to be able to also like contribute to the frontier of like the most exciting research. And in a sense, like I have friends at OpenAI and whose name you've never heard because they can't publish, can't really talk about their work, right? So like I think there's this component, but I think then we are basically, I think like now, like especially in the Western Hemisphere, I think like one of the only places that is really catching up to the frontier, right? Like there's obviously like Quen and DeepSeek and others in China, but I think it's really a fumble by like America, I think, to basically be the close guy that is like not
Yeah.
really almost like standing in for the values of like democracy and freedom to the same extent. But I think like he's obviously extremely passionate about like open source AGI and kind of like distributed like reinforcement learning. So like he immediately hit the ground running on basically scaling this much further. So we'll have more like yeah like work we are building on top of like this direction of distributed reinforcement learning like in the next few months already out, which should like scale this much further.
Mm-hmm. I remember
Very
a couple
cool.
of years ago I was using Octane Render, and they have a
Yep.
distributed rendering network where you can render CGI images on GPUs all over the world, and they actually have a crypto layer for render tokens as well. But this idea of distributed computation makes a ton of sense in that context because each frame is unrelated to the other frame. So you can, if you're rendering a 90 frame sequence that's a few seconds long, you can just send, each frame to a different machine. What have you learned from the successes and failures of the render network and what Otoy did with Octane? And is there any difference between those discrete individual frame generation and something as complex as training a whole model, where you in theory you'd need to load it all into one instance every single time?
Yeah, like great question. I think there's a few players like them and others that have tried this in the past, and I think they've been almost like in some ways, I think, too narrow and like too
Sure.
unambitious, right? It's like rendering like it's nice, but like it's not like the general purpose
Yep.
like use case that we now have with AI, right? So I think there's basically like our goal is really making this much more like general purpose useful for like every single like compute and AI use case.
Mm-hmm.
And I think that has been one big learning. It's basically being like most of our team are AI researchers and they come from the AI world,
Mm-hmm.
including the people that build, for example, the verification mechanisms, right? Like the verification in our case has like tiny overhead, like 1%. Like the more like crypto native verification mechanisms have more like a 1 to 10x overhead, which then make it completely like unfeasible to compete with centralized clusters. So I think that has been like a big learning is basically being very pragmatic and close to the AI researchers. So that's like the main community we're like building with and engaging with and basically building for, right? So like all of our users are AI developers. And ultimately, I think the biggest lesson has been is like just creating value for them from day one, right? It's like we launched basically our compute platform like 2 or 3 months in with like 2 or 3 people and immediately got like a lot of users and scaled since then. Like basically that like any kind of like AI startup or developer can just like basically with our platform almost like have like a global market on the one side, right? Like we aggregate all the hyperscalers, all the different data centers, even working with like folks like Aaron, like you later have on from Hydra, like and
Nice.
all these guys to basically aggregate and orchestrate like all these different data centers and hyperscalers. And I think that has been another lesson is like we're not trying to be like the exclusive maybe marketplace where supply onboards. We just aggregated all the supply out there, which gave us a huge kind of like wedge maybe to like enter the market.
Okay, talk about some of the hardware where this is actually running a 30 billion
Yep.
parameter model. At floating point 16, you're going to need 60 gigs of RAM. You're probably going to be on H100, not gaming cards. But are you thinking about bringing residual capacity online in the gaming market, or are these like small data center operators that just have a stack of H100s that they're not using and then they're bringing them online?
Yes, so basically, I think what's been exciting is like actually this run was heterogeneous. So H100s and A100s could join, and I
Okay.
think it maybe even like H100s. And like for future ones, like actually for next one, we're starting like even 3090s and like gamer
Oh, wow.
cards can join. And I think what's interesting is
Yep.
you can basically with like this rollout generation and like basically synthetic data generation, you can distribute the tasks like basically based on their like difficulty to different cards, right, and to different models. So the goal really is like to have like a fault tolerant, like heterogeneous, like pool of compute, right? So like what's also a big one that we did already in the first run, but also in this one is fault tolerant. So it's not only that you have like H100s joining and A100s and 3090s, but they can also drop out, right? Like they can join for a few hours when they're idle. And I think that's like the broader thesis is like almost like every GPU that is like idling is like a market failure, right? Like especially in a world where increasingly, like my theory is like the biggest almost like commodity in the world will be compute, and like it will be one of the biggest slices of GDP. And it's like unfortunate if like half of that is like sitting idle instead of like curing diseases, generating like movies, or like some like creating basically technological progress, right? And I think the goal is to basically just get to like 100% utilization of compute, and we're very, very far from that.
Yeah. Well, what are you seeing in like the trend in chip size and scale? You know, obviously NVIDIA's pushing those like DGX like rack mounted units, racking everything together with NVLink, so you can do even bigger models. Cerebras is scaling up the single chip size to wafer scale. The theme of the last few years seems to have been let's not decentralize. Let's actually centralize further. And so where does this go? What is your take on kind of the ever bigger racks and ever bigger chips for larger compute training?
Yeah, I think we'll see both. And I think actually, ironically, like an NVIDIA actually has an incentive to fragment the market. Like they don't want one buyer. They don't want AWS to be their only customer, because AWS is building their own chips, or like the big tech clouds basically like have their own chips competing with NVIDIA, right? So NVIDIA is very happy to give a bunch of chips to Core, a bunch of chips to Cruise, a bunch of chips to Lambda, and all of these other guys, right? But then, so I think we'll see both at the same time. Like I think like we'll have thousands and like millions probably over the next few years, like of data centers. There will be these gigantic clusters, right? Like Stargate from OpenAI. But I think at the same time, like there's increasing amount of like capacity in the almost like the mid tier of like smaller data centers. But then I think like also on the other side, like there's a lot of compute like sitting idle everywhere, right? Like soon in whatever, like autonomous cars, robots, like everything else. So we actually had like some of the biggest like car companies in the world reach out to us, or phone manufacturers that are like, oh, we're sitting on like hundreds of millions, like billions of like phones or cars that are like have idle compute capacity. And I think we're not there yet, but I think we'll have just much more compute everywhere, right? Like we'll have more like mega clusters, but we'll also have like more mid-tier and small clusters.
Mega clusters.
Mega cluster.
Mega clusters. I have a question before you leave. Yeah. Can you give some any expectations around DeepSeek R2? I've seen some crazy rumors flying around online. I don't know what's real and what's fake news, information warfare. I'm curious what you're expecting out of the next release.
Yes, like I think they'll definitely catch up to the frontier. Like again, I think to some extent, I think they'll probably be not as good, would be my guess, as like Gemini or OpenAI. But I think there's obviously this trend where I think like and all the closed lab CEOs have admitted it, right? It's like that open source has catched up like very uncomfortably close to their lead. And I think that will continue. I think the closed guys obviously have some advantages, but I think there's also huge advantages obviously the open source AGI space has. So I think like the trend will continue, that ultimately like the DeepSeeks and the Quants of the world, but hopefully also like players like Llama will like catch up a bit more. Like obviously they've been a bit disappointing with their like Llama 4 launch, but I think they might also actually like catch up again. And then obviously I think like our goal is like to be able to basically build on all of these on all of that progress, right? It's like basically we kicked off our like largest synthetic data generation run the day DeepSeek dropped, and like generated basically a lot of like verifiable like reasoning data that we could then use, for example, in this recent model. So I think the like what I see more is like basically that we can like improve open source AI progress like literally day by day, week by week. Like it won't be a thing where we need to wait like 4 months for like some progress to come, but it's more like continuous basically progress.
Well, thank you so much for joining. This was a fantastic conversation.
Yeah, I really enjoyed this. And congrats on scooping WB. Man, legend.
Truly, congratulations
truly legendary
on the
pickup.
Trade deal.
Yeah.
But
come back on again soon. I know you guys are going to have a bunch of launches coming up, and appreciated your perspective.
We'll talk to you soon.
Appreciate it.